Hi, welcome to today's topic that is building embedded systems projects in Linux. My name is Carlos and this is provided by GearTech. Okay, to begin with, introduction is to talk about the build tools that we have in embedded systems. And in the embedded software development, the build tools runs in the host computer. That differs from the target platform that we have, and it's the microcontroller. And these tools, the build tools, can barely make assumptions about the target platform because they are allocated in the host, right? So the process to go from the source code to an executable binary image, there are 3 steps. The first is to get all the source code, compile it and assemble it to a single object file. The second one is of the object files in the project, we're going to link together and have an output called a relocatable file. And the third one is to reallocate that file to the assign the physical memory address to this program. We need to make clear the difference between the host and the target platform, because the host computer compiles, assembles, links and locates all development to produce an executable that it's an executable binary image that will work in the target platform or in the embedded system that is the same. So we're going to start with the steps. The first one is compile. The principal task of the compiler is to translate the program right in the human readable or a high level language to convert it to the machine language. So almost always in the embedded system we need to cross compile. What it means it means that the host computer runs the compiler and produces a program for the target platform. So for example, you might compile something in your general purpose computer and the target platform is a mobile. It can be an external sample. Regardless of the input, a cross compiler has always an object file as output. And the object file is formatted binary file that contains the translate set of instructions and data that the file cannot be executed directly. So the structure of the object file can be understood. There are 2 standards. The first one is a common object file format. You can see it in the presentation in the slide, or the executable and linkable format. I think that the last one is the most used. Okay, let's talk about a little bit about the object files. And the object file is the data in the object file is grouped into sections. For example, in GCC, there is a good compiler in a GNU compiler among Linux distributions. Is that all the code it's in the block, and they are collected into a section called text. We have another section for the initialized global variables. It's called data. For the uninitialized global variables, they are in the section called BSS. There is also in the object files a symbol table that contains the names and locations of all the variables and functions in the source code. And they are referred in the source code. So you can see here, let me put the pointer. We covered that we have our source code integrated in C and C++, then it passes to the compiler. The output of that compiler is an object file, and then we go to the linker. In the linker we have the output of relocatable. We're going to talk about later. And in this relocatable, only in the embedded system we have an additional step that is the locator, and the output is an image, an executable image for the embedded system. So in this slide I would like to talk about the linker and the purpose of the linker is to combine object files and resolve all unresolvable all unresolved symbols. We have a GNU linker, and it's called LD, and it's a command line tool that takes object files and library as argument. So for embedded systems, we have an additional special object file for startup code. This startup code object must be included. So the symbols are, we're going to talk about symbols with you know that there is a table of symbols that we explained in the previous video, in previous slides. So symbols are the names of the variables and the functions. If a symbol is declared in more than one object file, the linker will complain. It will throw an error and it will show in the ID that you are using. And the linker also will try to resolve unresolved reference on its own. One example is a standard, maybe a standard C or C++ library function, where the linker will examine each specific library that we actually their parameters in the command line, and it's going to examine all the specific libraries, and if it's able to resolve it, then this symbol will be appended to the output of the linker. So the LD linker avoids add unreferenced functions to its output. And by the way, the LD output is an relocatable program where in this file there is no memory addresses that have been assigned to the code. And this is the next step. This special step for embedded system building is the locating step. But before talking about the locating step, I would like to talk about the startup code. This is just a diagram because I couldn't find anything regarding the startup code. But it's an idle and it's startup. It does some function there and then returns to idle. It's just that I couldn't find anything. So the startup code is a small block. Typically, it's a small block of assembly code, and this is to prepare the execution of high-level languages software. And typically, we have, for example, a startup code where the first step is to disable all interrupts. And the second one is to initialize data from memory, and the third is to zero now initialize memory. The fourth is to initialize the stacks following to initialize the stack pointer, and the last one is to call the main. And you might also find the startup code after the main exits. It sometimes happens, and usually you need to insert the startup code to the linker, another object file, and there is a GNU package called libgrooves, which with a variety of startup codes that you might find useful for your development. So the last step is the locating, and after the locatable linker output, you must provide information about the targeted allocation of memory. It depends on the target. The locator is a tool to assign physical memory to the relocatable code. And by the way, the locator is built into the linker in the GNU tools. And to locate the code, you need to write a link script. But before talking about the link script, I would like to notice something, that the locator produces a binary memory image that is the one that we need to our embedded system that can be located into the target, and this image is the last step to download into the target system. So talking about the link script, you can see in your screen that we have an example of it where starting assign the memory for the ROM and the RAM, and we have our section with the assignment of memory. Such script establishes the physical location of each section of memory. So that's it. Hope you enjoy.